Hello students, once again welcome to Bholanathacademy. In this video students we are going to see questions. What are polysaccharides? And we are to explain its classification and the structure of starch, cellulose and hyaluronic acid. Now polysaccharides are polymer of large number of same or different monosaccharides. Polysaccharides are the polymers of large number of same or different monosaccharides. The polysaccharides are chemically classified in two categories. Homopolysaccharide, that means the monosaccharides are what? Same monosaccharides. When so many same monosaccharides join, they form homopolysaccharides. What is heteropolysaccharides? When different monosaccharides join, they will form heteropolysaccharides. And here we have given the example. In homopolysaccharide, the example is starch and cellulose. And heteropolysaccharide, where the different monosaccharides are joining by glycosidic bond, that is example is hyaluronic and heparin. These two are the examples of heteropolysaccharides. Now students, we are going to see the structure of starch which are present in homopolysaccharides. We are going to see the structure of starch. It is a polymer of alpha D glucose. When so many alpha D glucose molecules joined by glycosidic bond, they will form the starch. So starch is a polymer of alpha D glucose. Now students, starch, when you see the structure of starch, it is made up of amylose and amylopectin. Understanding there is two component. Starch is made up of two component, amylose and amylopectin. In 100% starch students, 15 to 20% are amylose and 85 to 80% will be amylopectin. When you see students, amylose, they are water soluble. Amylose are water soluble. And which type of glycosidic bonds are present students? Here 1,4 alpha 1,4 glycosidic linkages are present in amylose. So students, when there is alpha 1,4 glycosidic linkage, that type of alpha D glucose we call as amylose. When there is a alpha 1,4 glycosidic as well as alpha 1,6 glycosidic bonds or linkages are present, that type of alpha D glucose we call as amylopectin. Because of these two bond students, these are what? Water insoluble. Understanding students, very important. Why it is insoluble? Because of this one extra bond 1,6 glycosidic linkage. So this is the amylopectin is water insoluble and this is water soluble. Amylose are water soluble. Understanding students, now we are going to see the structure, how we are going to draw the structure alpha D glucose. First we have to draw the structure of alpha D glucose. So here students, I am drawing 4 alpha D glucose. So this is the Haber structure students. So this way you can draw the pyron ring. First you draw 4 pyron ring like this students. So this is the first pyron ring, this is second, third, and this is what? Fourth pyron ring. Understanding students? Now because it is a polymer of alpha D glucose, okay students, and which time 1,4 glycosidic linkages are there students. So this way students, because carbon is tetravalent, so you have to fill the valency like this. So this way students, you have to draw the structure. Okay students, now here students, this is carbon number 1, 2, 3, 4, 5 and 6 will be here, CH2OH. Same way here also students, carbon number 1, 2, 3, 4, 5 and 6 will be here. Very simple way I have drawn the structure students. In examination, this way you have to draw the structure. Second carbon, third carbon, fourth, fifth, and this is what? 6th carbon. Okay students, now fill the valency, this tetravalency by hydrogen hydroxyl. Now here, because of there is a 1,4, which type of linkage are there students? Alpha 1,4 glycosidic linkages are there. Glycosidic bonds are present. Because of 1,4 glycosidic bond students, this is carbon number 1 and this is what? 4. That is why it is 1,4 glycosidic bond. Glycosidic bond, that means these two carbons are connected by oxygen. Understanding? 1 and 4s are connected by oxygen. By elimination of water molecules, they will form the 1,4. Why it is alpha students? Because this is the alpha carbon. All are what? All are alpha carbons. Because this is the ketone group. Before ketone, the carbon which is coming now students, that is we call as alpha carbon. So that is why the bond name is alpha 1,4 glycosidic bond. Understanding? Now fill the valency with hydrogen and hydroxyl. So this way students, alpha D glucose you have to fill like this. In carbon number 3, OH will be above and hydrogen will be below. Okay students, same way you have to fill here also students. So it is a polymer students. So this way you have to show the symbol. They are go on combining. Here also students oxygen. So this is the structure of amylose structure. They are in series. All the alpha D glucose are present in series. So this is the structure of amylose structure students. Amylopectin students, how you are going to draw? Again, because here there is a presence of alpha 1,6 glycosidic linkage. Here two rows you have to draw students. So students, first I am drawing the alpha D glucose. So this way two ring pyron ring I am drawing above. This way you have to draw the structure students. Very simple. Okay students, below students, in between bond there is a bond of glycosidic bonds are present. Now first students, you draw the structure of alpha D glucose in series. So this is the alpha D glucose students, carbon tetravalency. So this way you have to draw. This is carbon number 1, 2, 3, and this is 6. And between there is a 1, 4 glycosidic bond. This is carbon number 1, 2, 3, 4 carbon. 1 and 4 there is a glycosidic bond. Here students, in carbon number 6, because there is a presence of alpha 1, 6 glycosidic bond. So students, this is first series and this is second series. So this is carbon number 1, 2, 3, 4, 5, and this carbon students, this is carbon number 6, where it is connected by this carbon with oxygen bond. Understanding? So that is why this is called as alpha 1,6 glycosidic bond. Understanding? And here it is present 1, 4. This is carbon number 1. So 1, 4 glycosidic bond are present in this series. So this way students, you can draw the structure. So this with the structure of amylopectin students. It is coming in homopolymer because only one polymer monosaccharide we have used, that is alpha D glucose. So this is the structure of starch. So starch is made up of two units, that is amylopectin and amylo structure, because here is the presence of alpha 1,6 glycosidic bond. It is insoluble and it is what? Water soluble. Understanding students? So starch is made up of two parts, that is amylose structure and amylopectin structure. Now students, we are going to see the structure of cellulose. First, what is cellulose? It is a long straight polymer of beta D glucose. Okay students, so structure, it is a long straight, that means all beta D glucose are present straight in one line. So structure of cellulose, it is a long straight polymer of beta D glucose. It cannot be digested by human beings due to absence of enzyme, because humans are not having that enzyme. That is why they are not able to break this series beta D glucose. Understanding? Enzymes are absent in human beings, and very useful for bowel movement. Understanding? Due to the fibrous nature. Understanding students? This way your stomach will be free from unwanted material because of the bowel movement, because of fibers are present inside the cellulose. This is a polymer of monosaccharide is what? Beta D glucose. First we will draw the structure of beta D glucose. Now students, again you have to draw the pyron ring. So this is the structure students, because glucose is present in closed chain structure of glucose. So draw the pyron ring like this students. So here I am drawing 3 pyron ring students. With the help of these 3 pyron ring, we are going to explain you the structure of cellulose. Okay students, because carbon is tetravalent, you have to draw the structure like this students. Okay students, this is carbon number 1, 2, 3, 4, 5 and 6 will be here, CH2OH. Same way here also students, draw the tetravalency. Carbon number 1, 2, 3, 4, 5 and this is what? 6. Same way here also students, carbon is tetravalent. So this is carbon number 1, 2, 3, 4, 5 and 6. Okay students, because you have to draw the beta D glucose. When there will be beta D glucose students, when the hydroxyl will be above. Okay students, so here will be the hydroxyl group students combined with hydroxyl group which are present at here. So students, this is OH and they will form the glycosidic bond with like this. Okay students, so OH will be here, it will react, they will eliminate the water molecules and they will condense and they will form the 1,4 beta 1 beta 1,4 glycosidic bond. Glycosidic bonds are present. Okay students, so this is 1 and 4 carbon number students, that is why it is 1, 4, and why it is beta, because hydroxyl will be above the ring. Understanding? So now fill the valency students. Same way here also students, glycosidic bond will be like this. So it is mostly N type students. Understanding students? Now fill the valency with hydrogen and hydroxyl. So this is the, this way here students, carbon number 3 hydroxyl will be above the ring, and again students, here will be the oxygen. Okay students, same way here students, fill the valency H, OH. OH will be above and hydrogen will be below. Here also students, since here will be the oxygen, it is combining, hydrogen will be below. So this is the structure students. When it is go on, it is a polymer of beta D glucose. So this way students, now fill the valency with hydrogen and hydroxyl. So this is the structure of cellulose students. Very important students. They are present in the plant. Mostly it is cellulose are present in the plant. Okay students. So this is the structure of what? Beta 1,4 in bond is beta 1,4 glycosidic bond. Very important students. This is the also a homopolymer. Now we are going to see the heteropolymer example students, where different monosaccharides are. Different monosaccharides we are going to use. Okay students. Different monosaccharides are present students. We are going to see the structure of hyaluronic acid. We have two monosaccharide. First monosaccharide is D gluconic acid, and second monosaccharide is we are having N-acetyl, we call as NAG. Okay students, so these two are monosaccharides students. With the help of these two monosaccharides we are going to draw the structure of hyaluronic acid. Okay students, again students, what happens, you have to draw the pyrrone ring. Very simple students, this is the pyrrone ring. And this we are going to draw the structure. This is carbon number 1, 2, 3, 4, 5 and 6 will be here. Same way here students, carbon number 1, 2, 3, 4, 5 and 6 is what acid. Now students, NAG, if you draw the second different monosaccharide, that is NAG, that is containing carbon number 2 will contains nitrogen and carbonyl. Okay students, so this is the NAG. Now there is an alternate NAG monosaccharides are there students. This is carbon number 1, carbon number 2, this is carbon number 3, 4, this is carbon number 5, carbon number 6. Mostly students, this carbon number 3 with a methyl group that is involved in the bonding. So I am drawing like this students. This methyl group is involved in the bonding. Understanding? So 1 and 3, these carbons are involved in bonding. So these are the bonds are present students. So here two types of bonds are present, beta 1,3 glycosidic bond and beta 1,4 glycosidic bond. So two types of bonds are present students. So this will be the structure of the heparin. Understanding students? So this way I have drawn the structure of hyaluronic acid. Very simple students. Now second we are going to see the here students, we have two type of monosaccharide. First is called as D glucuronic acid and second monosaccharide is here students, again you have to draw the 4 pyrrone ring like this. So students, this D-glucosamine N sulfate. So this is the structure I am drawing students. One monosaccharide will be D-glucuronic acid and second will be D-glucosamine N sulfate. This is 2 D-glucosamine N sulfate and 2 D-gluconic acid. Understanding students? Now because carbon is tetravalent, so this way students, one carbon, this is the carbon number 1, this is 2, 3, this is 4, this is 5 and this is what, because it is acid, so this part is going to convert into acid. Okay students, because carbon is tetravalent, so this way students you have to draw the valency. This is carbon number 1, 2, 3. Again here students, this is carbon number 1, 2, 3, 4, 5 and this is CH2 O SO3H. This 6 carbon will contain the again sulfate group. Now between carbon number 1 and 4 there is a glycosidic bond. Now fill the valency, students. So this way I have filled. This is your D-glucuronic acid. So this is the structure of heparin. Very simple, students. Here we have used two monosaccharide. First one is D-glucuronic acid and second monosaccharide is glucosamine N sulfate. This is glucosamine N sulfate. These two are glucosamine N sulfate and this is D-glucuronic acid. Understanding, students? So this way, this is the heteropolysaccharides. So this is very important for the examination point of view, students. So in examination, this way, students, you can draw the structure, which is very easy, students. Like my video, please share it, subscribe it. Thank you very much. Have a nice day. God bless you.